Hello everyone. Well, we are already at chapter 8 now. So in chapter 8, in this module, we are going to talk about the energy of orbitals. Now this chapter will build up using the quantum mechanics that we just learned in our last chapter to talk about some periodic properties of our elements. A lot of you have already done this already. We're going to get into the trends in atomic radii and ionization energy and so on. Also, at the towards the end of the chapter, we have electron configuration. But first, let's go over the energy of orbitals. Well, here, what are the factors that are going to affect our atomic orbital energies? Now, the energies of our atomic orbitals, they're going to be affected by our nuclear charge. So this is our nuclear charge, and if you guys recall, this is our Z. When we did isotopes, that's your Z. And something called shielding by other electrons. So our energies are affected by the nuclear charge and shielding. We're going to go over what shielding is. A higher nuclear charge, should have made this space bigger, increases our nucleus electron interactions and it lowers our sublevel energy. Now, shielding by other electrons, it will reduce the full nuclear charge to what's called an effective nuclear charge. Okay, effective nuclear charge. And the symbol we're used for that is Z effective. And again, I'm going to go over shielding a little bit later on, but I'm just going over factors that are going to affect our orbital energies. And our Z effective is the nuclear charge that the electron will actually experience. Okay, and again, I'm going to go over it in more detail, but it's the actual charge that electron actually experiences. And then what's also going to affect our sublevel energies is the shape of our orbital. So we learned about orbital shapes in the last chapter. And here our orbital shape is also going to affect that energy. Okay, so we are going to look at hydrogen again. It only has one electron, and then we're going to contrast it with atoms that have more than one electron. So we call those multi-electron systems. But our hydrogen atom, so let's go back to hydrogen. We know it has one electron. Now orbitals here, so I showed this picture in the end of chapter 7. And what I want to point out here is that if you have orbitals that are in the same principal energy level, so say like n equals 2, they have what are called degenerate orbitals. Degenerate orbitals. So that's just a fancy word for they are going to have the same energy. And that's what they look like here. So we know if we have the energy, we have n equals 1. Here is our n equals 2. Here's our n equals 3. So all of these orbitals, so you know we have 3 orbitals, or the p has 3 orbitals. So here they all are going to have the same energy. And notice here that the 2s and 2p have the same energy, right? And then over here for n equals 3, look, the 3s, the 3p, and our 3d all have the same energy. So these are degenerate. Now, what happens is that once you get past having just one electron, so atoms with more than one, well, when you solve the solution or the approximate solution to the Schrodinger equation, you start to see that the sublevels are no longer degenerate. They're actually going to split. And that's what you should have remembered from intro chem. And if you didn't, don't worry, we're going to go over it again. But here, if you have more than one electron, our sublevels do not have the same energy. So our 3s is not going to have the same energy as the p, and which will not have the same energy as the d. Well, what are we going to look at? What determines that? Well, first is going to be our principal quantum number n. So it depends on the energy of our orbital, depends on that. It depends on the angular momentum L. And the lower the L within a principal level, the lower the energy of our orbital. So I have it written here, but we remember from when we did electron configuration, hopefully. So our energy, S has a lower energy than P, then D, then F. Okay? And This is what we called the Aufbau principle in the past. So this was our building up principle. Okay. Now let's take a look at this. So on the left, we have hydrogen atom. Again, notice that in each principal energy level, they're degenerate, all the same energy. But let's look at what happens when we have atoms with more than one electron. So here we start to notice a splitting of our sublevels. So we see 1s here, then it's 2s, but look, 2p is higher. Then we go to 3s, which is higher than 2p, but look here, the 3p is higher than the 3s, 3d is higher than 3p. And you can see the same throughout potassium. Now, this Aufbau principle, you learned this while you did electron configuration. So a lot of you learn this way. I teach it more by the periodic table method, which you'll see. But if you know it this way, that's fine. But you just put the arrows through the 1s. So here's your 1s, and you guys would go 1s1, and then you go 1s1, 1s2, so on. So, and then you would count as a whole, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, oh, and then it would go back down to 3d. So that is our building up or the Aufbau principle. So hopefully that's just a little refresher for you guys. Okay, and then you could just see the increasing energy over here as we go up to the F's. But this is how I teach it as well. So here we have it derived from the periodic table, and we have it in blocks again. So here's our S block, and then here's our P block, D, and then our F. And then you go across. So if we were to build it up, you would start here, you go 1s2, and you go back around, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. So again, our sublevels are not degenerate, right? They're not all the same energy. All right, so that's what the Aufbau principle says. You fill up the lowest energy first, and then you go towards the highest. Now, there are three concepts as to why our energy of our orbitals are not equal. So these are why our energy levels split. Coulomb's law, shielding, and penetration. Now, Coulomb's law, I forgot to say that these three concepts are associated, all of them, with the energy of our electrons that are in the vicinity of our nucleus. So Coulomb's law, this describes the interaction between charged particles, the shielding. Let's say it's how one electron can shield another from the full charge of a nucleus. And then penetration. This is how one atomic orbital can overlap spatially with another. So it can penetrate into a region close to the nucleus, and therefore it's going to be less shielded from the nuclear charge. Now I'm going to go through all of these in the next module. So I just wanted to get to here, and then I will go ahead and describe Coulomb's law. Then we'll go into shielding, and then finally penetration. Okay.